So, good morning. Just want to welcome you guys to the first day of Summer School August. So just like today, every single day, Monday to Friday, I'll be doing a Zoom session for 1 hour. Let me start with the land acknowledgement. We acknowledge we're hosting the lands of the Mississauga of the Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nation, Métis, and Inuit people. Okay, I'm hoping everyone here has watched the orientation video. Okay, and after watching the orientation video, you realize that this course is a lot. You need to spend 6 to 8 hours a day on working on learning the lessons. Okay. Every day I give you guys a quiz after the lesson. You have like the whole day to do practice worksheets, which I'll give you, which is like, for example, today. And then you can work on the quiz. Okay. And then after a couple of days, you'll have a unit test. There's 5 unit tests. Okay. But there's a quiz like almost every day. So there's a lot of quizzes, and then I'm not going to break down every little thing. The worksheets, you can hand it in or you don't have to hand it in. Okay. The quizzes count for marks. Understand that. Every day the quizzes are counts for marks. So that's what it is, counts for marks. Okay. There's practice quizzes in the end, which are just to, I guess, they're formative, but these quizzes count for marks. So they're not formative, they count. Okay. Okay, so let me get through this because I only have an hour, so I have to get through the lesson. So any big questions, you guys send them to me some other time, like through email, but I gotta answer, I gotta go through this lesson. So today is unit 1. We're gonna talk about definition of a function notation, investigating domain and range, and then we got 2 worksheets you guys can do on your own. And then there's a quiz, and the quiz is due today. Let me make sure I can see what you guys see. So I'm going to come in as a student. So I'm going to view this whole thing as a student, see if I can see what you can see. Because I can see everything, but I want to make sure you see what you need to see. Okay, so we go into content. Okay, that's where the lesson's going to be at, and the video lesson and the lesson. Unit 1. Okay, so unit 1, here's the lesson, here's the video, here's another lesson, here's the video. The worksheet should show. I'm surprised it doesn't show. Okay, let me stop sharing my screen for a sec because there should be a worksheet there for you guys to work on. So hold on. I don't know why it's not showing. Give me a second. Take a look at that. What's going on? Yeah, it's there. Edit it. Over the time. No, it's not that time. It's supposed to be this time. Okay. Let me fix the next one. Yep, just made some mistakes there. Okay, so it should show now as a student. Okay. Okay. So let me share my screen so you guys can see that. Okay. So here you go. Here's a worksheet 1, worksheet 2, based on the lessons. So let's start with the first lesson. I'm gonna play the video, then I'm gonna stop the video in some spots, and then I'll further emphasize some of the points of the video. Okay. So this one here is going to talk about functions. Okay, so that's the key, the difference between a relation and a function. A relation is just basically two, oh, no one can hear? Okay, so I did something wrong here. Hold on, let me back up. Okay.
Here's the first lesson for the grade level.
Can you guys hear now? Did you guys hear the video? Okay, my bad. I was playing it, but I forgot to, you guys can't hear the sound, so I had to share the sound as well. Okay, so here we go again. So we're talking about what is the definition of a function, okay? And a function, let me fast forward a little bit. We're here, you have a relationship and you have a function. A relationship is basically a function when you have one value for x, and the way they put x is the independent variable, okay? And one value for y, which is the dependent variable, okay? So I have a graph here. Let's say the graph looks like this, okay? And I pick a point on the graph somewhere here. Here's my point. Okay, that point there, there's only one value for x. Here's your y axis, and here's your x axis, okay? Sorry about the handwriting, but there's only one value for that point, right? When you go across, there's one value for y. You go down, there's only one value for x, okay? So this is a function. Now you may have a graph like this. I'll draw another graph over to the side here. And the graph could be, let me use a different color. Maybe it looks like this. Maybe the graph looks like that, right? Maybe it looks like that, right? It could, right? Now, Is this graph a function? The question would be, is the graph a function? Well, if I look at a point here, where I'm putting right here, now I go across, there's a X, there's a Y value, and there's X value. But if I go down here, on this point, wait a minute, on the graph, so this X value here, okay, has two Y values, has a Y value coming this way from that graph, point of the graph, and one Y value coming this way here. So this is not a function because it says here, one, you can see where I'm missing my mouse, one value of a dependent Y variable. Okay, so this is not a function, but this is a function. Okay, you're going to see more examples of that. Okay, so let me fast forward. Okay, there we go.
Value that corresponds to a given X value. That's the most simply put definition there. For a relation to be a function, there must only be one Y value that corresponds to a given X value. And we're going to look at a few examples represented in all of these different ways to be able to tell if there's only one Y value for a given X value, to be able to determine if a relation is a function or not. And I also put a little note here just for you to know that all functions are relations, but not all relations are functions. Functions are special types of relations where there's only one Y value that corresponds.
Okay, so we get that. So let's look at an example here. Here's an example. Okay, so here's a table. And the question is it a function or a relation? Okay, so if I look at this table here, right, y equals to x squared. Well, x squared, you know, is a parabola, right? Right, x squared is a parabola. So if I'm looking at, if I plug in a value for y, if I plug in a value of x, I can get only one y value, right? Minus 3 squared gives you 9. Okay. And so on, right? So if you look at here, my x value, each of them has different y values, right? So one x value, another x value, so it doesn't repeat, all right? So if I were to draw that, this particular graph would look like a parabola, okay? You guys can see on my screen there, right? So I have a point here and a point here, point here, point here, but they're different x values, okay? This one over here is not the same, right? So my x values, if I were to draw this, maybe use a different color so you can actually see. I'll use red again. So if I'm gonna graph this, if my y value is 3, I get 9, right? -3, I get 9, because -3 times -3 gives you 9. But if my y value is 3, I also get 9. That means for my x value, I'm getting two different y values. So what that looks like, it will look like something like this. Like I was showing you before, it looks something like this, right? If I say y is -3 over here, and I plug in -3 into here, well, -3 squared gives you 9. If I plug in 3 inside here, well, 3 squared also gives you 9. That's not going to be a function. If I plug in 2 here, I get 4. If I plug in -2 here, I get also 4. So again, it's not a function because it has two y values for the same x. Okay, that's what we're saying. So I'm going to fast forward because that's what he's going to say. Okay, so it's going to say the same thing. So here's what I was saying about the one that was x equal to y squared. You can see there is for the y value, for the x values, if my x was, say, 1, I have 2 y values. If my x is 4, I got 2 y values, right? And so on. So that's not a function. So I'm going to play the video from here so we can hear what he's saying.
What we're going to want to be able to do is use these graphs to determine if these relations, y equals x squared and x equals y squared, are functions or not. We're going to use what's called the vertical line test. Just to introduce you to the vertical line test.
So the vertical line test is another way to determine if something is a function. And he'll just talk about it right now.
What we're going to do is draw vertical lines through x equals -2, -1, 0, 1, and 2 on the graphs of both of these relations. And then we're going to check, is there only one y value for each given x value? So if I draw those...
Okay, well, I mean, we already can see if I were to draw a line, say at 1 over here, I have 2 y values, right? If I draw a line at, say, what's the next one? X is 2. Okay, and then over here, if I draw a line at when x is 1, there's only one point. My lines aren't straight, but you get the idea, right? There's only one x value for one y value. Here, for the one x value, I got 2 y values up here and up here, right? So another way to just determine is the vertical line test, okay? That's another way to determine if it's a function. If it's only one point that goes through the line, then it's a function, okay? And that is what's going to be said just now.
Vertical lines on these graphs, this is what it looks like. And these vertical lines are actually going to be...
So you can see, right? One line, I got 1 point, 1 point, 1 point, 1 point, therefore that's a function. Okay, so here you're saying it's not a function because you got 2 points there. And yes, this one is a function, okay?
Relation in more than one spot. If we look back, so I'm going to show you how we could have determined this before graphing without the vertical line test.
Okay, well, you can also, okay, let's see what he's going to say, but...
If we look at our table...
And I already talked about this, he's going back to the tables. If you go to the tables, you can see that this one's a function because if I look at my x value, each x value is only one y value, right? Different x values, different y values, right? X value only has one y value. Over here, I have x value 9, but then I also have, so my y value is 3, but then with the x with my x is 9, I also have a value of, well, I have a -3 and a 3. That's 2 y values for my 9. That's not a function, okay?
Table of values. So let's look at, why is x equals y squared not a function? Well, hopefully what I want you to notice is, if given the ordered pairs, we have an x value that is repeated. If you have x values that are repeated and have different y values associated with them, it is not a function. Because...
Okay, so there you go. Let's fast forward to something else. Okay, so we talked about that, why it's a function and why it's not a function. So we look at this question here. I mean, if we're going to use the vertical line test to determine if this is a function, yes, it's a function. This is a straight line, and this is the vertical line. As I move the line across, it's only going to hit one spot of that line. So that line it's going to have one x, one y value, right? So as I move it across, the answer is...
It passes the vertical line test. So this relation, y equals -4x plus 5, is a function. This relation is a function. No vertical line can be drawn that passes through more than one point on the line.
Okay, only 1 point. Of this one here, as you can see, as we move this across, you're gonna have more than 1 point that crosses the vertical line. So this is going to be not a function. Okay, so I'll fast forward a little bit. Right, this is not a function. Okay, more than 1 point of the curve. So the line hits more than 1 point of the curve. Okay. The next one, C, probably going to be pretty the same. It's going to be pretty easy, right?
As I pass it through the relation, it's never touching the relation in more than one spot. It passes the vertical line test. This one is a function.
Okay, this one right away, again, if you pass this across, it's a circle. The line's going to hit 2 spots. If it hits 2 spots on this curve, which is a circle, it is not a function. Okay, so that's what's going to happen. There you go, 2 points there. It's not a function.
But as it goes through, for example, if I stop it at x equals 2, it is passing through the circle there and there. Since there are more than one y value for x equals 2, it is not a function. So under here, relation, not a function. Next thing and last part of this lesson is you're going to learn how to state the domain and the range of a relation. So let's get the definitions out of the way.
Okay, when we talk about domain and range of a function, and we're talking, when we say the function is the curve, right? That we just saw, that is not a relation. So the domain talks about the limitations of the on the x-axis. Okay, all the possible values of x, and then the range talks about all the possible values of y. Okay, so again here it says right there, the independent variable is always the x. Is called the domain of the relation. Okay, the set of corresponding values for the dependent variable, which is often the y value, is called the range. Okay. So here we go.
Relation. Note, for a function for each given element of the domain, there must be exactly one element in the range, meaning for each x value, there must only be one corresponding y value for the relation to be a function. And we've talked about that a lot already. More simply put, domain and range. Domain, values x may take. Range, values y may take.
Okay, so basically all the possible values for x is the domain, all the possible values for y is the range. Okay.
I'm going to show you just a little interactive activity here, just to maybe get you to be able to visualize domain and range.
Okay, so this one here, this is a graph that maybe 2 lines put together. Okay, and you can see that it is a function, because if I do the vertical line test, there's only 1 point the line would cross on this graph. Okay, so you know it is a function. Now, what is the range and domain? So let's look at the domain. If I'm looking at the domain is dealing with the x values, right? So my domain actually goes from here, where my mouse is. Okay. I'm going to put a red dot there. So from here, and if I move this across, it stops here. So my domain is from there to here. My domain is from here to here. That's my domain. That's where this graph exists. My range, I'm gonna use a different color. I don't know, I'll use this color. So I stop here and I go down to here, looks like. And I don't go past that. I don't go any higher. I don't go any lower, right? Because even here is still lower than that. So my domain is from 3 to whatever that is. I guess that's 7. Okay. My range is from 1 to 9. Okay. So that's what we say are the ranges for this graph. Okay. I'll just play the video and you'll say the same thing.
So I have a relation here, and for this relation, it only exists between 1 and 9. Most of the relations we look at are going to continue on forever, but for this one, it just exists between 1 and 4. So if we want to look at the domain and range, domain, we're looking at where does the function exist along the x-axis? Which
Okay, so he's going to slide. So he's showing you the domain is sliding across. Oops. There you go. He's showing the domain where I highlighted, right? It goes from 1 to 9, and the range goes from 7 to 3. So he's showing you what the domain and range is. Okay.
the range of the relation, the range means what y values can the function take. So we'd be looking at the y-axis. Where does
Okay, so I kind of talked about all of that. So there you go, the domain. And this is called bracket notation, right? He's showing it like this on the bracket notation. Grade 12, you'll learn bracket notation, but it's fine. There's another way to write this, but it's showing the domain is between 1 and 9 and the range between 3 and 7.
inclusive? We're going to write domain and range different than this notation, but this is just a good way to help you get started understanding. So the domain is where does the relation exist along the x-axis, the range, where does it exist along the y-axis? Okay, so let's go back and try a few examples of this. Here's the notation that we're going to use.
Yes, so this is the general notation that you use, okay? The other notation was called a bracket notation. That will be in grade 12. But in grade 11, use this notation. So this would say like x is any real number, and it could be between, a number from here to here. That'll be, say, your domain. Or you can say your domain is x equals to this number, this number, this number, this number. Okay? It all depends on what the graph is. Same thing for the range. Okay? This is sort of something that's continuous. This one here is something that maybe it's just points. Okay? And I'll play it. Let me play the video so you can hear what he's saying, but I'll emphasize what he's saying also.
This means any type of number, rational or irrational number, includes integers, terminating decimals, repeating decimals, non-terminating decimals. It's basically saying the function exists everywhere along the x-axis.
So he's talking about what that R is. R is a real number. It could be any kind of number from decimals to like just any kind of repeating decimals, like integers. That's what real number is.
Except this is a given that sign. This means given that we're going to have to state some restrictions on.
Okay, so this line that he's talking about will state the restriction of the domain. So it's any real number, but the restriction is maybe it's between 3 and 6, something like that. Okay, that's what that means.
On the domain sometimes. Maybe there's an asymptote somewhere and x couldn't be a certain value. Maybe x only exists between certain values, like in the example.
Yep. Okay, so you still.
Sorry, in the example we did here, x was only between 1 and 9. So.
Okay, so let's fast forward a little bit. This is discrete. This is where you're just looking at points. Let us hear his explanation for that. There you go.
1 less than or equal to 9. If we have a discrete function, meaning the function only exists at certain points, we will actually write the x values of those points.
Okay, like I said, if these were points, right, then you just write the x values of the points. So x equals to this point, that point, that point. That's it. Okay, and it'll be the same thing for range as well. So let's fast forward that. Okay, so the question is, let's back up. These are examples now. We're going to go through some examples. Okay, I'll play it from here.
Okay, so we have
Okay, here's an example. Determine the domain range of each of the each relation from the given data, okay? Okay, so this is one data, you're given points, right? So now you're given points, determine what is the range. So the range, you're just looking at, sorry, the domain, you're looking at all the x points. So so the domain would be, so if you were to write this out, really and truly, it would be x is any real number, but x equals to what, -3, 5, -2. You already have 5, and then 6. Okay, and then the range would be any real number at y is equal to whatever you have on over there. 4, -6, 7, 3, 8. Okay, so that's how it would be written. Okay, this one over here, your range. So the same thing, right? You just pick out all the x points for your domain, and your range, you pick up all the y points. Okay. Then the question says, are these relations functions? Well, going back to what makes a function and what makes a relation. Well, functions is when you only have one y value. So I'm just going to clear the screen for every x. Okay. So this one here at -3, -3, okay, it's only one. Here, I have 5 as my x. Oh, but then I have here a y at -6. Oh, I also have here a y at 3. So this is not, okay, it's not, because I have two different y values for the one x. Over here, is this a function? Let's see here. Different different x values and different y, yeah. So yes. Okay. So this is a yes, this is a no. Okay, this is a function, this one is not a function. Okay, so let me clear that. I want to fast forward, he'll explain that too, but let me just fast forward it so we can kind of just see the answers. Okay, so he's talking about domain right now. So you can see domain is equal to that, range is equal to that, okay? And then here he was talking about what the domain and range is again, just put all the points. Okay, domain, all these points. And then now the question is this a function? Are they functions or just relations? So there you go. See, I highlighted x has two y values. So it's not a function. Okay, so a is not a function because when x is equal to 5, it has two different corresponding y values. And b, this one here, b is a function because for each element in the domain, there's exactly one corresponding value in the range. So it doesn't repeat. Okay. So these ones here determine if it's a range, determine the range of each. I think I'll let you guys do this on your own because I think this is pretty much getting easier now. Okay, so I'll let you guys finish the video on your own, but you're just gonna do the vertical line test after you graph it. You can see it's only going to hit one spot. So let me fast forward this one. So, and then from there you can determine the domain. And he's showing you what the domain is. It's any real number. There's no restrictions for the range. So for the domain, there's no restriction. It's gonna the line with the arrows going up and down means it can go forever up and forever down. So therefore, there's no restrictions on the domain, and there's going to be no restrictions on the y. So y could be any real number for the range, and for the domain, x could be any real number. Okay. I want you to catch what he just said.
Restrictions on the range. The range is an element of real numbers as well. That basically means y could be anything. Let's do another relation. So we have a quadratic relation.
Okay, so this one here, if you look at this, this is a quadratic, a parabola. You guys remember this? So this would be your vertex 1 and 3 would be your vertex, and you draw the parabola from there. So let's fast forward, look at the parabola. There you go, that's your parabola. The domain, there's no restrictions on your x. You can got the arrows. It can go forever this way, or it can go forever this way. So x is any real number. The domain is any real number for x. There you go. But the range, there's a restriction for the range, because my y is no lower than 3. As you can see here, my y isn't lower than 3, right? But it goes up forever. So my domain will have a restriction of y is greater than or equal to 3. Okay? So y could be any real number, but y has to be greater than equal to 3. Let me fast forward. Let me play it from here.
Always greater than or equal to 3. So what this means, y could be anything given that y is greater than or equal to 3.
Okay, let's go to the next one. This is a radical function. Okay, so you have to graph it, and you can see once you graph it. Oops, I did the whole thing. Okay, so once you graph it, when you look at this radical function, okay, and you can also look at it by graphing, but if you look at the actual equation here, x has to be, right, when you look at this, has to be 1 or greater, okay? If x is less than 1, then you're gonna have a minus inside this square root sign. And you can't, that means if it's a minus, you can't square root a minus. It's undefined. If you put that in your calculator, it'll say error. So x has to be 1 or greater than. If it's 1, then this whole thing is 0, you can square root 0. And if it's greater than 1, then you can still square root that. But if it's less than 1, you can't square root that, you'll have an error. So 1 has to be greater, x has to be greater than 1, therefore my domain is x is any real number, provided that x is greater than and equal to 1. Okay? Now, when you look at your range is basically, because you have a +3, it's making sure you start at the 3 versus starting at 0. So as a result, since I start my graph at 3, it is any real number, yes, but my graph has to be greater than or equal to 3, okay? And it keeps going on forever, but it has to start at 3, okay?
Here. And notice for this relation, I should draw my little arrow here. So this relation would continue forever in that way, but it will never be to the left of that point there. It starts here and continues off to the right forever. That's why the domain, it says x always has to be greater than or equal to 1. It's at 1 on the x-axis here. It'll always be at 1 or to the right. It continues off to the right forever, but it can't exist over here. Why can't it be to the left of 1? Why is there no corresponding y value for an x value of -1? Why doesn't the relation exist over here? Well, let's look. If I was to take this -1, this x value of -1, and plug it in up here, I would get the square root of -1 minus 1. That's -2 plus 3.
Okay, he's basically saying what I told you. You can't have anything negative in the square root, so it's not going to work. So watch.
And we can't take the square root of a negative number. We can't do it.
Okay, so that's the reason why. Okay, so let's fast forward. Okay, this is again sort of just asking a question: what's the domain and range? Okay, that's the circle there, and it's going to be in between, right? It's a circle, so you know it's not. It's not a function, but the domain and range is going to be between the points of x can only be in between -6 and 6, and y can only be between -2 6 and 6, okay? So let's, we're done with this one because I think that's the main things for this. Now I'm gonna go to the next, we don't have much time left. So let's go to the next lesson. So hold on. That is, we're done with that. So the next lesson is over here, okay? Let's continue here. Function notation. And I don't think this is going to be that hard because we kind of talked about function notations anyways, but I mean, you kind of seen it, but we'll talk about it.
Here's lesson 1.2 for the grade 11 functions course. This lesson is called functions and function notation. So now that you know what a function is, from last lesson, we looked at different relations and determined how to classify those relations as functions or not.
Okay, so you know what a function is. We talked about it. If it's a function or a relation, we talked about it. But we want to be able to write something as a function. So what does that mean? What does it look like? Okay, so what does a function do? Okay, so this is where in the past we were writing things like this, right? Let me write on the screen. Y is equal to x squared, right? That's what we've been doing in the past. If we're writing an equation, that's a function, y is equal to x squared. But we're going to change it. Instead of using y, we're going to substitute y with f of x. So it's going to be written like this. Okay, that's what we say in the what's the function notation. Okay, this here, and it's telling you right there, replace y with f of x. So the way you can pronounce it is, or read it as f at x, f at x, that's usually what I say, or f of x, okay? So what does that mean? That means if you look at over here, my output is my f of x, but my output is dependent on my input. So whatever is my input, whatever is my x, will determine what is my y or my f of x. And when you think about it, when you are to graph this, we said the x is always the independent, right? And the y is the dependent. And y is dependent on x. So when you think about it, x, whatever x is, it will influence what y is. So y down here is a function of x. Y down here is dependent on x. I'm playing on words here. Okay, it's a dependent of x. Okay, so that's why you write it like this, right? We write it like this because we're saying x will determine what y is. Instead of writing it like this, we write f of x. Okay, that's what this whole unit is, or this whole lesson is about. Okay, so let me play the video and you'll see what I'm talking about. Okay, so I'll play it from here.
Function notation is going to look very similar to equations you've used in the past, with one key difference. Instead of having y equals something, you are going to have this, f at x, or f of x, it's sometimes called, equals something. So what does that mean? So basically, first of all, what is a function? So a function is an equation that takes x as an input. So you pick a value of x, you plug it into the equation, and the function spits out a corresponding value of y. It tells you the value.
Okay, whatever input is for x gives you the value of y.
Of the function at a given x value. So we are now going to, instead of writing y, instead of using the variable y for the value of the function, we're going to use this notation, f, and then in brackets beside it an x. We're going to call that f at x, or f of x. That means the value of the function at a given x value. And that's going to replace y. So function notation, this is what it looks like. Like I said before, this f with the x in it, with the x in brackets beside it, means f at x. we can take any value of x we want, plug it in, and then our equation will tell us the value of the function at x. That's why we write it like this, f at x equals, and this f at x replaces y. So if you want, think of it just as like y equals. So let's practice using.
Okay, so that's the main thing there. Now, basically, we can look at different ways to do this, right? To use the function, right? So we're saying here, if you look at this function right here, right? So normally you would have wrote that as y is equal to 2x minus 4, but now we're writing it as a function of x, right? So that means we can change the values of x and say, what is the value, right? What is the value at 2? And if I were to do that, then wherever I have x, I plug in 2. So 2, right, minus 4, right? And then the other time would be, what is the function at 5? So wherever I have x, I'm going to plug in 5. And then my next one is, what's the function at a half? So wherever I have x, now I'm going to plug in a half. Okay. That's basically what we're doing here. Okay. If we were to do the math here, this would be, I guess, 2 times 2 minus 4. This would be 0, I guess. And then here, 2 times 5 is 10 minus 4 is what? 6. 2 times a half is 1 minus 4 is what? Negative 3. Okay. That would be the, the function, the values of the function for each of the values of x. Okay. And that's what we're doing here. That's not hard, I think. I think that's sort of just kind of simple. So let us play the video and get to that.
Using this notation. So the question says, for each of the following functions, determine f at 2, f at negative 5, and f at a half.
So I'm just going to fast forward. Okay. You get 0, like I said over there, and you're going to do the same thing for each one, right? So yes. So what he wrote there now is, okay, let me just make sure you copy and see that. So whenever x is 2, my y is 0. Okay. So wherever my x is 5, my y is 6. Whenever my x is a half, my y is negative 3. Okay. So when my x is 2, my y is 0. That's what we're doing there. Okay. That's important. Oh, I could be wrong for the second one. Huh? 2 times, is it 2 for the second one? 2 times 5. Isn't 2 times 5 10? Minus 4? Isn't that 6? I don't know. Does that make sense? Okay, well, we'll see it. I mean, the whole point is 2 times 5 is 10, isn't it? Right? Minus 4, isn't that 6? Okay, so Arish, I think you're right. Yeah, it's 6. Okay, so again, you gotta be able to do your arithmetic, right? The process is there. You gotta be able to do your arithmetic. Arithmetic is just to be able to subtract and minus. Okay, so let's continue. I like that discussion there. So we're fast forwarding. Now we're looking at when x is negative. Oh, my bad. It's negative 5. Oh. See, you guys are discussing. Good. Look, see, you caught me. X is negative 5. So if x is negative 5, so then my answer is wrong. If x is negative 5, 2 times negative 5 is negative 10. All right, negative 10 And then -4 is what? -14. Right? So yeah, I was wrong. It's -14. My bad. Okay. Okay. So let's continue. You fast forward. You're gonna do that. Now it's gonna do that question. Yeah, -14. There you go. And if you do the half, so whenever x is -5, my y is -14. Now we're gonna do the next one. Yep, we got -3. So whenever x is a half, my y is -3. Okay, there you go. Makes sense. Okay, so let me clear the screen. Continue from there.
Just the y value when x is a half. Let's do one more practice equation this time.
Okay, so he's doing another practice equation, but he's using the same variables, -5, I believe, and I think a half and 2. Okay, so just fast forward that when x is 2, what is y? So it's just, again, just doing arithmetic. So I don't need to go through this. I'll just show the answers. Okay, when x is 2, y is 17. For this, and this is a quadratic, right? Because you got x squared, so you know this is a quadratic. And if I do the next one, when x is -5, what is y when x is -5? It's going to be 87 when x is -5. And when x is a half, the next one, plug it in. When x is a half, yeah, there you go. X is a half, y is 29/4.
Is a point on the graph of the function f at x equals 3x squared minus x plus 7.
Okay, so we're gonna fast forward. And basically this is gonna graph for the function, graph it and find the domain and range. So, I mean, we can graph that. That's sort of gonna be, you have your, this is gonna be a parabola, right? As you can see, there's a negative there. So if you remember from grade 10, that would make it go down. But here, I can find my vertex. So my vertex is going to be at what? -1 and 5. So my x is -1. My y is 5. So somewhere there. And this is just a what do you call it? A sketch. It looks something like that, right? It's probably not accurate because I'm using freehand. I'm drawing on the screen, but it looks something like that. Okay. And then what is the domain and range? Okay, so I'll just fast forward that because we talked about that from the previous lesson. Okay, so it looks more like that. Okay, so I want to erase my graph. So that's what it looks like, right? So the domain is any real number. There's no restrictions for x, but the range is it can't be higher than 5, right? So the graph cannot be higher than 5. Right? There you go. So y is less than 5. Okay, so let's doing more of the same. Okay, so, and then you plug in different values to figure out. So I guess the question, what was this question here? Find f of -7. So therefore you plug in the value of -7, find out what the f of -7 equals to. Okay, and so on. Okay, so that's what that is. Okay, So let me go to here. Let me go to the very beginning. Okay, so we did function, function notation, domain and range. So you got worksheets here. Okay. Do the worksheets will help you to, I won't go into it. It'll take me to another screen. Actually, you know what? I'll go to it. Let me just go to it. Just it's not for marks, okay? So don't think this is for marks. So click on it, do the worksheet. Okay, so here's one worksheet. Okay. And then the answers at the bottom here. Okay. And so function, domain, and range worksheet. And then you click on the next worksheet. By the way, it's all in the content, okay? It's all in the content. So if you can see here, it's in the content. Okay, it's not like I'm giving you the hot link to where find it, but it's already in the content. So you click here for the sheet. Here again, let's go through the questions. Okay. Determine the function at 4, 5, and so on. Okay. So that's what you're working on. And then there's a quiz afterwards. Okay. So let me go back. And the quiz, I go to the home page. Let's double check. You guys can see the quiz. I click on the quiz. Takes to where the quiz is. Yeah, the only thing you had in is a quiz. But again, like I said, the worksheet, you got to work on the worksheet because you're going to say, sir, I'm stuck. And if you're stuck on something, whoa, let me make sure the quiz is active. Can I take the quiz at the time that it's inactive? Okay, let me double check that. Okay. So don't leave yet. Give me a second. Give me a second. Okay, I got to do one thing at a time. I got to make sure your quiz works. So give me a second. Hold that thought. Okay. Hold that thought. Give me a second. That's why. Make it visible. Okay. So just make it visible. Okay, so share my screen again. Okay, so I'm gonna share my screen again. When I click on the quiz, it takes you to the quiz. Okay, you're allowed 2 attempts. Okay, and you can see the quiz will end at it's only I can't remember how many questions, a few questions, it's half an hour, but it will end, meaning you got to do the quiz before 11:59 p.m. today. Okay, so yes, this is the only thing that you're handing in that counts. Okay, yeah, it's multiple choice. Okay, it's in the quizzes, so it's multiple choice. Okay, so that is what is due today. Do the worksheets though. If you don't do the worksheets, you won't be ready for the quiz. Okay, so that is it for today. And somebody had a question?
Yes, sir, I have a question.
Okay, go ahead.
It's my first online class, and I want to ask one question. Every day we have just 1 hour for
Yes,
le-
just like I said in the orientation, I said this in the orientation, right? Every day, as I said in the orientation, every single day you have 1 hour, 9 to 10, or maybe it's just today's 10:06. And then for the rest of the day, you should need to spend 6 to 8 hours a day on learning the lesson. So that's why I give you worksheets, 6 to 8 hours a day, and then you'll be able to do the quiz. Like I said, every single day there's a quiz. Every single day I give you worksheets. And in a couple of days, let's say Monday. No, Monday's a holiday. I want to say by Tuesday, you're gonna have the first unit test, right? Actually, you know what? Let me share my screen. Let me share my screen with everybody here while you guys are all watching, because some of you guys may not have checked everything in the content section. So you guys can see my screen, right? If you go under content section, it tells you when all the tests are. When I go into course information. So here I have the course calendar. Also in the course outline, will tell you the same thing, but maybe you want to see dates and maybe it's more visual. I have a calendar here. So let me show you the calendar. And if you look at the calendar, it tells you everything, right? Today's the 31st. Let me zoom in a little bit. Today's the 31st. So we talked about this. And then we have a quiz that's due today. Tomorrow's the 1st. There's another quiz, number 2. And then on Friday, quiz number 3. We have a civic holiday on Monday. So there's nothing on Monday. Remember that. Monday's a holiday. Then we have quiz number 4, okay, which is talking about radicals. And then on Wednesday, we go into doing unit 2, but even though we're doing unit 2, that day, I give you unit 1 test, okay? And then it's due the next day, okay? So this calendar can help you, okay, to keep track of what things are due. It tells you what things to do, the quiz, and then the unit test. These when it says unit assignment is actually test, okay? So you can see here, unit 1 on August 7th, it's due the same day. And then quickly, we're doing unit 2 now. And then right on the next Friday, unit 2 test is happening. So within next week, you're gonna have unit 1, unit 2, just like that. So you need to be on top of the game because you're gonna be overwhelmed. And before you know it, midterm marks are right here on August 14th. And it's gonna be based on unit 1 and unit 2 test. And then all the quizzes up to here, okay? And already here you can see August 13th, unit 2 test. So they come in quickly, right? So that's why people cannot miss dates. They can't think I just need an hour, that's it. I'm gonna test you on everything. So you need to be on the ball. Okay, this is for everybody. This is for everybody. I'm not talking just to you, everybody.
Okay, and can we write an answer to for example, our worksheet, or no, we should just put our answer in your worksheet that you submitted?
So I'm sorry, could you just repeat that,
For
the
example,
question?
I write my answer in my own sheet and then submit it. Is it possible or no?
The worksheet, you can submit it because it's I have it there as an assignment, but I'm not counting it. That's what I said in the, if I show you what I said
So we
in,
can write just answer in our sheet.
yeah. But again, for the quiz, you need to do it online, right? But the worksheet helps you to understand. That's the bottom line. It's for you to study, to help you understand. You
Yeah,
get
I
that?
know. But I ask for question is, for example, I write my answer, just I write the answer, not the question.
Mhm.
For example, I take one paper and write my answer and then submit it.
If you want to submit, are we talking about the worksheet? What do you want to submit? The worksheet? What are we
Yeah,
talking about?
yeah, the worksheet.
Yeah,
Just
the
answer
worksheet.
of the worksheet.
if you want to submit it, I'm not marking it. That's what I just said. I'm not marking
okay.
it. So you don't have to submit it.
Oh,
If you want to submit it, it's up to you, but I'm not marking it.
oh,
I'm only going to mark the quiz. That counts. And then the unit tests. So
Oh.
everyone gets that, right? The quiz and the unit test is what I'm marking.
okay, thank you.
Okay. Okay. And the worksheet is for you to understand. You need something to practice, right? That's why I give you the worksheet. The worksheet goes with the lessons that I give you guys. So the lessons that I give you, then you have the worksheets to help you to understand. To be honest, what you can do is maybe practice submitting, but I don't think you need to submit. Okay. I don't want to put that burden on you, because in the past I told students to submit it, but I'm not marking it. So then it's extra work for you guys to submit. But I'm going to mark the quiz and I'm going to mark the unit test. Okay. So that's what matters the most. Hopefully that clears up everything. I know it shows an assignment as a worksheet, but it says there, doesn't count for marks. So when you said doesn't count for marks, that means you don't have to submit. Okay. And you're not going to lose marks for not submitting. And this is being recorded. So you can, I'm going to put the recording, and when I'm done with this session, I'm going to put the recording under here, under class recordings, and you can come see if you missed the beginning, or you went to the washroom, or you missed something I said. This is all recorded and it's going to be over here. Okay. So that being said, I'm going to stop sharing my screen. It is past the time. I'm going to stop recording.